Okay, let's take a look at number 64. So now we have powers of 4s. Notice there's no cubic term. So first, any restrictions on the x's? No, you could take any number you want, raise it to the 4th power. So we take the derivative just using the power rule. So the 4 comes down, 4 divided by 2 is 2. 3 times 2 is 6, and this becomes a 4. And now we have the problem. If I try to set this equal to 0, right, I'm going to try to factor something with a power of 3. And notice what I've done is I've just to simplify it a little, I pulled out the 2 from everybody. 2 is a positive number, so I don't have to worry about that. So now what I'm going to do is create a new function, just this part, forget about the 2. So I have an x cubed. Notice, folks, I don't have any x squared terms. Please put in 0, x squared minus 3x plus 2. Now, hint, you might want to consider this function. So it's just the what? The first derivative without the 2. That doesn't hinder anything. So I'm making this new polynomial. Notice I have no x squareds. And out of the blue, I'm going to pick 1. And I'm going to put it in here and see what happens. So I have 1 cubed here. Obviously 0, 3 times 1 plus 2. And voila, 1 and 2 is 3 minus 3 is 0, which means what? X minus 1 is a factor of that. Which means you could do your long division, right? Notice I have to put in 0x squared in there. So x, what times x gives me an x cubed? X squared, put it in the x squared column, subtract. What was originally positive becomes negative. What was originally negative becomes positive. So x squared plus 0x squared is just x squared. Bring down to 3x. Now what times x gives me an x squared? An x. Put it in the x column. X times these two guys is x squared minus x. Subtract. So what was originally positive becomes negative. What was originally negative becomes positive. So we're up 1, we're down 3. You owe me 2 x's. Pull down the 2. What times x gives me a negative 2 there? Excuse me, what times x gives me an x? It's just a 1. So we're going to have, what times x gives me negative 2? Minus 2x plus 2. And notice we have a remainder of 0. Okay, so that's 27. So in other words, we're trying to find critical points, right? So remember we had all this multiplied by 2. That's irrelevant. So now I look at this, and we can go through the same thing with factoring, but take a look at 2. What are the only factors of 2? 1 and 2. And the fact that right here, 1 and 2, the fact that we have a positive means I should be able to factor this. And notice that we find a negative 2. So if I put in a negative 2 here, so if we go to long multiplication and long division, I put in here, I get a 0. Now, the reason I'm doing this is x minus a minus 2 is a factor, which means x plus 2 goes into this with a remainder of 0. And once again, you could do your long division. So what times x gives me an x squared? X. Multiply, you get 2x. Now subtract, so 1x minus 2x is negative x. What times this gives me, excuse me, the x, that's got to be a 1. So then we bring that down, and we have a negative 1 times x, and a negative 1 times 2, and guess what? The remainder is 0. So all this means now is this part can be factored into x plus 2, x minus 1. And you could have seen that much sooner, right? If you look at the factors of 2, they're 1 and 2. And a positive 2 and a negative 1 is going to get you the positive x. So we could have done it directly. All right, so here's my derivative, my first derivative. I'm not dividing by 0, so I don't have to worry about that. So I set this equal to 0, and we get, excuse me, two possibilities. 2 cannot obviously be 0. X could be 1, or x could be a negative 2. So what this is telling me is, here's my negative 2, critical point, here's my 1, and I have 3 regions. I do the same thing. So I pick a nice number in region 1, in other words to the left of negative 2, which would be what? Negative 3. I want a nice number between negative 2 and 1, how about 0? I want a nice number bigger than 1, how about 2? So if I put in negative 3 into my factored form, I get, 2 is a positive number. So if I put in a negative 3 minus 1 squared, a negative 3 plus 2, all I care about is this positive or is it negative? This guy is positive, the 2 is positive. When I square a number, I get a positive. And this is a negative, so it means negative, which means in region 1 it is decreasing. Let's move this up. Let's pick a nice number between negative 2 and 1. How about 0, right? 2 is a positive number. 0 minus 1 squared, that's a positive number. 0 plus 2, positive. All are positive, which means it is increasing in region 2. Region 3. Want a nice number to the right of 1? How about 2? Okay, so I just put it into my derivative, my first derivative. 2 is a positive number. 2 minus 1, positive, positive. All are positive, which means it is what? Increasing. So, decreasing, increasing, decreasing. So this would look like a local minimum. This would look like a local maximum. So how do I figure out what this minimum value is? I put the negative 2 not into the derivative, but I put it into the original function. Okay? So I'm saying there's a local min. I want to know what that y value is. So I put the negative 2 not into the derivative, but into the original. Do the arithmetic, and I come up with a negative 20. Okay? So what does that mean? At x equals negative 2, this minimum value, the y value, is negative 20. How do we figure out what this local max is? Do the same thing. I put the 1 not into the derivative, but I put it into the original function, because I'm trying to find out what this y value is. So I put it in, and I get a negative 13 over 2. So the local max is a 1, and is located at x equals 1, and the local max is a negative 13 over 2. Notice, folks, this is a local min, and this is the local max. Okay.